So this is the final meeting of the semester before the final exam. So hopefully we'll be in a good way by then. So the first question says we want to find the area of the region bounded by these two curves. Well, that's a circle and that's a cardioid. So the wisest thing you could do is just do a rough sketch. Now, your sketch is not going to be perfect, okay? So little things like, for example, I really need to know where these intersect, if they intersect at all. So let's do that first. When will 4 equal 4 minus 4 cos theta? Well, that will happen when 0 equals negative 4 cos theta, or cos theta equals 0. Well, cos theta equals 0 at pi over 2 and 3 pi over 2 if I'm just going from 0 to 2 pi. We know that this graph will complete it, both graphs will complete themselves from 0 to 2 pi. So I don't really need to do the k pi thing here. So to make it easier, I'm going to draw the circle first. Now, they intersect here and here. When theta is 0, I'm at 0. When theta is pi, I'm over here. Therefore, I know the graph's going to look like this. Okay. The question is, find the area bounded by these two curves. Well, there's only one region bounded by these two curves, and that would be that there. There are multiple regions here. Okay, there's several ways, and we did this problem in class, or one like this. If I said find the area inside the circle outside the cardioid, that'd be this area here. If I said find the area inside the cardioid but outside the circle, that'd be here. So we're finding the area bounded by both, that's this. Well, when I'm taking an arbitrary sector, I'm going from origin to cardioid, but over here, I'm going from origin to circle. So there has to clearly be two different problems going on here. Now, you can actually be really lazy on this one, because if you do notice, everything to the left of the y-axis is just the semicircle. And I know what the area of the semicircle is. That's how I can be lazy, but I'll set it up as an integral. Here, this is interesting though, because that's 0 to pi over 2. That's 3 pi over 2 to 2 pi. So technically, my overall area will be technically 3 integrations. The first bump here would be 1/2 r squared, but my r will be this guy. Plus, from pi over 2 to 3 pi over 2, 1/2 r squared, but that will be my r. So that's just a constant. Plus 3 pi over 2 to 2 pi. Oops. And again, I'm the 4 minus 4 cos theta squared, d theta. Okay, now here's where we can be a little bit lazy. Because of the picture and the symmetry of the picture, the area of that piece right there is exactly the same as the area of that piece right there. So can anybody tell me what I might want to do just to make my life easier? That. So that's that. That's that. Is there something I could do that might make this a little easier? Anybody? Nobody? Go ahead.
Just multiply it by 2?
But do one of them and multiply it by 2, exactly.
Oh, yeah, that's what I mean.
The area is exactly the same. So what I did on the key was I said, okay, let me just take this guy and multiply it by 2. Okay, that definitely will make it easier because the cardioid is not that fun to integrate. So I'm going to go times 2. Now, this is the easy piece. Okay, that's a semicircle. I already know what the answer is, but if I continue this, that's 1/2 of 16. So this guy here will be 16 times pi over 2 to 3 pi over 2 of d theta, which is just 16 theta from pi over 2 to 3 pi over 2. That's a gap of pi, so that's 16 pi. Okay, If I did that, no, hold on a second. Is that right? Or did I lose something? Oh, sorry. That should be 8, not 16. Sorry about that. It's like, well, that seems too big. 8 theta. Now, could we have justified that? Well, a circle of radius 4 isn't the area pi times 4 squared. So a circle of radius 4 should have area of 16 pi. This is exactly half of a circle of radius 4, and we got 8 pi. That's exactly what we're expecting. So our final answer should be 8 pi plus that part. So that part's a little bit more intense. So I've got to square this. So let me go ahead. I don't need this anymore. So when we square 4 minus 4 times the cosine of theta, I'm going to get 16 minus 32 cos theta plus 16 cos squared theta. And now I need to use my double angle formula on the 16 cos squared. So that'll be 1/2 of 1 plus times the cosine of 2 theta. Well, 16 times 1/2 times 1, that's 8. So I'll add it to that 16. So now I'm at 24 minus 32 times the cosine plus 16 times the cosine of 2 theta. So that represents r squared. Okay. So if you notice here, it was 1/2, but because we doubled it, that makes it a little bit easier. So this part of the problem is now going to be the integral of 24 minus 32 times the cosine of theta plus 16 times the cosine of 2 theta d theta from 0 to pi over 2. I've already doubled, so the 1/2 and that will cancel. So now I just need to integrate this, and that's really not that terrible, okay? That particular integration, if I pull that off. So let me go ahead and erase this. So this will be 24 theta minus 32 times the sine of theta. And then that will be plus 8 times the sine of 2 theta from 0 to pi over 2. Okay, well, let's see. What do we get in this case here? If I'm doing that from 0 to pi over 2, do I get anything that's not going to be 0? Yeah. So when I do it at pi over 2, I'm going to get 24 times pi over 2, that's 12 pi, minus 32 times the sine of pi over 2. Well, the sine of pi over 2 is 1, so that'd be minus 32. Sine of 0 is 0. Okay. Then when I evaluate at 0, I'm going to get 0, sine of 0, sine of 0. So turns out I get this. Okay. So at this point of the game, is this my final answer? Well, not quite. This was the little pieces. I have to add to this then the semicircle. So the total area would be 8 pi plus this quantity, or 20 pi minus 32. Now, what you will notice, the area of a circle of the whole circle would have been 16 pi. The area of the semicircle was 8 pi. My answer is just a little bit greater. 12 pi minus 32. How big is that? 12 pi minus 32. That was the area of the little pieces. That's about 5.7. That's not very much. So I have the semicircle and then just a tiny bit extra. So that's an easy way to justify that final answer. So this is the answer. So as you can see, most of us weren't very close on this one for the simple reason that we didn't draw the picture. We tried to do something completely different. On the final, any type of area problem that I ask you will resemble these questions. In other words, I will limit it. I will completely limit it to things like circles, cardioids, maybe a leaf of, like, sine 2 theta, those are those little leaf things, something where the region is really, really simplistic. There won't be anything complicated in that realm. So again, that kind of completes the big picture. Does anybody have a question on this one here, particularly? Any part of it you weren't sure? Or hopefully it makes perfect sense when you looked at the drawing, you go, oh yeah, I got to do these in pieces. Hopefully that made perfect sense to you. Okay, so that's everything. Now, final exam. We had 25 lectures for this course. And I mentioned this last week, and this is pretty accurate. If you could break up the entire course and say, what was the single most important thing we did each class? Okay, because some classes we did more than one thing. If we could say, what's the single most important thing we did each lecture, and say, now I'm going to put that question on the final exam, you have a pretty accurate final. That's about how long the final is. It's about 25 questions long, but you're not going to do every problem. This is one of those, because I have to spread it out over the whole course, I cannot ask you everything. So it's mainly big ticket items, but everything's going to have the same weight. And so you're going to do, I think, like 20 of them. So you can skip problems. If there's something you just haven't got down, it's not really a big deal. You just can't have a long list of things that you haven't got down. So if we're doing, let's say, sequences and series, and you go, oh, ratio test, I'm really good at that. Limit comparison test, I'm really good at that. Ooh, that looks like an integral test. I think I might skip that one. That's what you're going to do. Methods of integration, oh, that's clearly an integration by parts. I got that. That's clearly a trig sub. I can't remember how to do that one. Well, you skip it. Okay, you can do that all the way through the test. And again, you don't have to have 20 perfect questions. An A final is going to have 14 or 15 perfect answers, and then a few flawed ones that just sort of make up enough points. So this is basically a scoreboard. The more problems you attempt, the better you're going to do. So you cannot dwell on any one problem. You've got to get as many attempted. If you don't get 20 attempted, that's not a bad thing. I mean, if you only get 10 attempted, that would be a bad thing, because there's not a whole lot of points there. So every single thing in the course is fair game, but don't go after trivial detailed stuff. Okay, big ticket items. Now, what is there? Well, obviously there's applications. There's methods of integration. There's sequences and series. There's power series stuff, Taylor series, all that kind of stuff. There's some with conic sections. There's going to be some L'Hopital's rule, right? There's clearly some polar coordinates. I mean, you could probably argue, there's 80 to 100 questions that would all be fair game, but I've limited it to about 25 because, again, I wanted every single problem on there, you saying, okay, that I would consider that an important question. Being important doesn't mean it's long, not even close. Now, every single Calc 2 class I teach, generally speaking, we spend the review time going over the practice final in class. And what I've always done over the years is the students will present all the solutions to the practice final. We really can't do that in this environment. And I don't really want to send you all the breakout rooms to do that. So I'm in the process right now of writing the key to the practice final. I've never given a key to it before, simply because the students always presented all the answers. And then as a class, we went over to make sure they were all correct. So I'm in the process of writing the answers. I'm about 2/3 of the way through it. It took me about 15 minutes to do the first 16 problems. They just shouldn't take that long to do. I've got about, I think, 8 or 9 more to go. So I'll have that up really, really soon. I'm just double checking because I don't want any errors. But the practice final is a really good indicator. And I'm hoping that you guys have retaken some of your old tests. You've retaken practice tests, maybe even gone through some quizzes to say, yep, I know how to do these still. I don't imagine anybody had difficulty with like work problems at the beginning, a spring problem. That is like low level. But the problem is you haven't done it in over 3 months. So that's why you've got to go back and go through some of these, because you very well may have forgotten how to do certain things. So everything's fair game on the final. And now I want to reiterate, if you've already earned the A or a B, I've emailed you that you got an A or a B, and it was kind of hysterical. I've had about 20 students in one of my classes either get an A or a B so far. And I emailed them very specifically, and almost everyone has emailed me back. Okay, you said I got an A in the course, but does that mean I got an A in the course? And those were actually usually the words they used. I'm thinking, what part of you got an A in the course is confusing, right? They know how many points they have Canvas, they know how it works, and congratulations, you've got an A. Yeah, but I know you told me I got an A, but how do I know I got an A? That's kind of really a silly question. Yeah, if you look at the total points and you've exceeded the A in total points, you've got an A. Same thing with a B, same thing with a C. So let's say you're a C, you're shooting for a B. You're a B, you're shooting for an A, and you don't get it on the final exam. Well, remember, the final only counts if it exceeds your lowest test and 5 lowest quizzes. Okay, so you're taking the final to raise your grade. It has to actually be better than the scores that you're wanting it to replace. Otherwise, it doesn't count. So somebody who doesn't take the final, they get a 0 on the final, and then that's their drop score. Somebody who does take the final, it only counts again if it's better than the things it's replacing. And if it is, then your grade just went up. That's how you improve. And everybody here after today especially can figure out down to the point, how many points do I need on the final to raise my grade to this particular plateau. So if you've got a C or a B, I'm hoping you take the final to try to raise your grade. Okay. And if you've already got the grade, you can't lose it. So you're taking the final in that case, maybe just to say, what did I retain? And that's really important. I think the most important class to take the final in is Calc 1, because that's the one where a lot of folks say, I did well in the course, but I don't know at the end if I really remember everything I need. So most of my Calc 1As generally take the final exam just so they can confirm that they've retained everything necessary. Okay. Now, I'm going to stop in a moment, and I'm going to just make this office hours. So question I have.